welcome to another A-Level Computer Science video with me, Mr Goff, for MrGoff.com. This video will focus on communication methods. Serial transmission is a method for transmitting data from one device to another. Serial transmission sends one bit at a time down the same wire from the sending device to the receiving device. Very high speeds can be achieved, particularly where fibre optic cables are used to carry the signal. Parallel transmission is another method for transmitting data from one device to another. Parallel transmission sends multiple bits, for example a byte, at the same time, with each travelling down its own separate wire from the sending device to the receiving device. It may seem logical that parallel transmission would be more efficient than serial transmission. However, parallel transmission has two key problems. The first of these is skew. This is where slightly different properties of individual wires cause the individual bits travelling along different wires to arrive out of sync. This can lead to transmission errors as the receiving computer grouped the wrong bits. The other significant problem of parallel transmission is crosstalk. This is when the signal transmitted on one wire interferes with the signal on another wire and causes one of the bits to change. Crosstalk increases as the frequency of the signal increases, and both skew and crosstalk increase as the length of the cable increases. This means parallel transmission is only effective over short distances. Serial and parallel transmission describe the number of simultaneous bits that can be transferred during a transmission. We also need to know about a transmission's synchronicity. A synchronous transmission is where data is transferred at regular intervals timed by a clock that must be shared by the sender and the receiver. It is common for systems using parallel transmission to use synchronous transmission. Synchronous transmission sends chunks or frames of bits all in one go. Asynchronous transmission is where data is transferred one byte at a time, preceded by a start bit and followed by a stop bit. The start bit alerts the receiving device so it can synchronize its clock ready to receive the data. The data is transmitted with the 8th bit as a parity bit, followed by a stop bit. In this example, the character X is being transferred in ASCII with odd parity. This is why a 0 parity bit has been added, so that we ensure that there are an odd number of ones within the data. Asynchronous transmission is slower than synchronous transmission, but more cost-effective to implement. In asynchronous transmission, the start and stop bits create gaps between bytes of data, but synchronous transmission has no gaps between bytes of data. The speed of synchronous connections makes it suitable for uses such as voice over internet, video conferencing, and online gaming. The lower demands of services like email and web forums mean the more cost-effective and easy to implement asynchronous transmission is usually more suitable. That brings us to the end of this video on communication methods. Join me again soon when I'll be back with another video on communication basics. Use the resources at MrGoff.com to help you revise computer science. And until next time, it's bye for now.